Right. Welcome to day 4, I think. It's day 3 or day 4? It's day 4. Okay. Okay. Up till now, we have discussed about different type of the hazards, arc flash hazard, and electric shock hazard. Now, what about arc blast hazard and how it initiates? Everything basically initiates or starts with an electric arc. If there is an electric arc is there due to failure of insulation, due to narrow sizing or narrow gap between the bus bar, or due to drop tool, or it could be due to any other reason. Maybe there is moisture is there, and the and and the air have contaminated a bit, that is causing a bit of uh, the narrow, the gap between the conductors have narrowed. This might result in an electric arc. If the electric arc persists and the electric arc have enough capacity, then it is converted into an arc flash event. And if the arc flash event have enough capacity to basically cause the rapid expansion of air, then it is converted into an arc blast event. So a dangerous condition associated with the pressure wave component that occurs from the fault current during an electric arc event. So during a fault situation, there is an electric arc event, and then it is converted into an arc flash and arc blast. So the pressure wave is caused by a rapid expansion of air and vaporization of conducting material from those intense heat. So how it is different from an arc flash event? The arc flash is during an arc flash event, there is an energy release. Okay, during that arcing event, and that energy or the incident energy we calculate in calories per centimeter square. During an arc blast event, there is a high amount of pressure wave is released, or there is a pressure component, and we calculate that arc blast in terms of pressure or in terms of pounds per feet square. So this formula is not given in the standard. I've taken this formula from the handbook of 70. So in the handbook, they have mentioned the formula for calculation of the pressure waves component. So it is calculated in pounds per feet square. So the formula is 11.5 into IA divided by D raised to the power 0.9. What is IA? IA is basically the arcing current, and arcing current is dependent on the fault current. What is D? D is basically the distance from the center of the arc. So if we look here, the greater the distance from the potential source, what's this, Mohsin? Page 292K4. I think you are referring to.
That's the page number for the standard book, handbook.
Okay, yeah, in handbook is there. So greater the distance, the lesser the amount of the pressure uh, the person will going to receive when during this arc blast event. So this graph is basically not is related to the arc blast, but it is basically, it was for the incident energy which we saw. So similar type of the graph can be drawn for using this formula as well. So just increasing the distance in fits and keeping the arcing current constant, you can find what will be actual pressure at that particular location. So some facts about the arc blast: it results high pressure can easily exceed hundreds of kilograms per square meter. The sound associated with the pressure is around 140 decibels. The material and molten metal expelled uh, away from the arc at a speed of 1,000 km/h, fast enough for shrapnel to completely penetrate the human body. Okay, so these are the thing which or the further hazard which are associated with an arc blast event. On the other hand, with an R flash event, there is an intense heat is there, which can cause second degree or third degree burn. Moving to next definition of an arc rating. So we select this personal protective equipment based on an arc rating. So what this arc rating is and how this arc rating is defined. So basically, the arc rating, if you have any arc rated personal protective equipment with UPP, you will going to find that arc rating is mentioned in calories per centimeter square. So that means this arc rated clothing is basically there to protect you against an arc flash event. In the complete NFPA 70E standard, you won't be finding any personal protective equipment which is rated for pounds per feet square like this. So if an exam question comes that this personal protective equipment will going to protect you against all the hazards, so the answer is no. In case of arc blast, a person won't be surviving, or in case of an arc blast, there is a chances that different type of the injuries the person can get in that event. For example, if I have a car with me, so what's the purpose of the doors? The main purpose of the doors is to keep people safe who are sitting within the inside the car, so they might not going to fall uh, if during the drive. During any crash, the doors also provide safety to the people who are sitting inside, but it does not guarantee that those people will be safe. So what's the primary objective of the door? The primary objective of the door is to provide a safe area, sitting area inside the car. It is not designed to provide you protection against any crash or any other thing that you will be safe in that case. Similarly, if I have any special car design which is bulletproof or bomb proof, so the material which will be used in the development of those doors will be basically providing me protection against those specific threats. Okay, so in that particular case, the door might going to provide safety and security to the people who are sitting inside the car against those threats as well. So we can say that that design is basically to counter those type of the hazards as well. Similarly, people who are wearing like bomb disposable people who are wearing an special PPs and going for that particular activity. So basically those PPs which they are wearing will going to protect them against the blast pressure. Okay, so it will going to try to protect them the blast pressure. Here the PP which the 70E talks about, it has a rating given in calories per centimeter square. So if in the case of arc blast and the hazard which are associated with the arc blast, there is a chances that a person can receive certain amount of injuries. So only one PP which I have seen which covers the arc blast is the earrings, which says that you will be wearing some hearing protection to protect you against those high sound wave, which is around 140 decibels, which is generating during an arcing blast event. Okay. Any question on this point up till now? All good. So how it is calculated? How this is calculated. So there are two methods. One is ATPV and another one is EPT. What is termed by ATPV? ATPV is our thermal performance value, ATPV, and EBT is energy to break open. So the value attributed to materials that describe their performance to exposure to an electric arc discharge. So these are basically 40 cals per centimeter square or 30 cals per centimeter square. This basically is the value which we will going to provide to different type of materials, and they will basically show how the material will going to perform when it is exposed to an electric arc discharge. So ATPV is our thermal performance value, EBT is energy to break open. In this picture, we can see that there was an arc flash event, and this personal protective equipment basically break open. Here it break open, and the outer layer break open, but the inner layer remain intact, and the person or the wearer remain uninjured. These are some other examples of the PPs of damaged PPs which have faced the enough amount of the incident energy. So in all the example, what you are seeing, the suit rating is mentioned in calories per centimeter square. The amount of energy released is also in calories per centimeter square. No one is talking about pounds per feet square. So everything is covering the R flash event. So arc rating is reported as, this was one of the question I put in the starting slides when we were discussing. So if you have any idea about this question, just try to give your answer, then we'll discuss. Yes, answers please. Right. So arc rating is reported as D, T, and C. D is the right answer, either ATPV or EBT, whichever is the lower value. So why it is so? Just keep this answer in mind. In exam, this is this type of the question you might be facing, and in the standard, there is no clear reasoning for this option why it is like this. So let's try to develop the understanding of this ATPV and EBT. So what is ATPV? Arc rating is the value attributed to the PP material in calories per centimeter square that describe your performance when exposed to an electric arc discharge. ATPV is the 50% probability of second degree burn through the garment. EBT is the 50% probability of break open of the garment. So ATPV is defined as that in the event of an electric arc discharge, there is a 50% probability of break open, or sorry, there is a 50% probability of second degree burn through the garment, and EBT is basically the 50% probability of break open of the garment. These are basically as per the ASTM standard 1959. So if we talk about the ATPV, how ATPV is calculated. Let's take the example of a black and white shirt. So in hot weather, maybe during summer in Saudi Arabia, I'm wearing a black shirt. So there, after maybe 1 hour, 2 hours, if I'm walking outside, I might find my body has become reddish, or maybe I might have got sunburn. Uh, Still, I'm wearing that shirt. So that means enough amount of heat has transferred through that shirt which I'm wearing, and it has caused me certain degree of burn. That is basically the failure, or that is basically due to the type of the material of the shirt I was wearing. So that basically transferred the enough amount of heat. So this is related to an ATPV concept. in the ATPV concept, the specimen or is tested against different level of incident energy. The same specimen is first tested for let's suppose 1.2 cals per centimeter square. It is determined that no heat is transferred. Then the incident energy will going to increase from 1.2 to 2, 4, 5, 6 calories per centimeter square. Then in certain data point, it it became evident that when the incident energy was increased till 9.9 cals per centimeter square, so enough amount of heat start to transfer that may cause second degree burn. Above 9.9, the ratio or the probability of causing or the crossing of the heat become more and more clear or more and more certain. So for example, at the incident energy of 10.3, somewhere here, around 90% times that specimen transferred that particular amount of heat into the body. So it was determined that somewhere here at 50% probability, what's the 50% probability that enough heat will be transferred at what amount of exposure level? So it was determined that around when this particular piece of specimen is exposed to 9.9 cals per centimeter square of incident energy, 50% time there is a potential that the enough heat will going to transfer or the sufficient heat will going to transfer to the specimen, and it will going to cause the second degree burn. So this specimen is assigned a 9.9 cals per centimeter square of value based on ATPV. So they have assigned, okay, this particular specimen has an ATPV is equal to 9.9. That at 9.9 there is an enough heat is transferred through this material, which can cause a second degree burn. Then on the same piece of specimen, they have increased the incident energy from 9.9 to 12, then to 15, then to 20, then to 22. So at 22 cals per centimeter square, 50 times or the 50% times enough heat was being transferred through the specimen, and other 50 times it was not. When they increase the incident energy till 23.5, so there was around 90% times the now for the ATPV, EBT is about the opening, break open. When you are providing enough heat to the personal protective equipment, it will going to open and there will be holes created. So they observe that above 22 cals per centimeter square, it becomes certain that there were holes are being created in the specimen. So they assign 22 cals per centimeter square as a rating for the EBT. What will be the size of the holes which will be considered as a break open? A break open is a material response evident by the formation of one or more holes of defined size of an area 1.6 centimeter square, or an opening of 2.4 centimeter in any dimension in innermost layer of an R-rated material that would allow thermal energy to pass through the material. So EBT is basically the break open in which the holes are created, and ATPV is like it allows the crossing of the enough heat to cause the second degree burn. So for this particular specimen, if we talk about, let's suppose this one, we found that ATPV is 9.9 and EBT is 22 point something cals per centimeter square. Why we are purchasing this R-rated clothing? We are purchasing this R-rated clothing in order to protect our employees or the worker who will be wearing it. So we will going to look the lowest value, because above that there is a chances that that person will be will be having or will going to receive a second degree burn. So that's why the overall rating of this personal protective equipment will be assigned based on the lowest one. So in this particular case, it's an ATPV which was lower. So we will going to assign the overall arc rating of 9.9 cals per centimeter square. Let me show you some test reports. So this is test report of the personal protective equipment, which one of my client purchased from this company. They provided this test report that they perform the testing on that particular equipment or for that particular specimen. The test current was 88 kiloampere. This was basically the type of the things which they were testing. They analyzed 24 samples. Incident energy which they generated from 10 to 29 calories per centimeter square. They identify that the arc rating is based on ATPV 12 cals per centimeter square. Material break open was 12 cals per centimeter square. So the overall arc rating of that personal protective equipment was assigned based on the lowest of ATPV or EBT. So whichever is the lowest, we will going to assign the overall arc rating based on the lowest available incident energy. Yes, any question on this one or clarification required? All good. Right. So what actually the ATPV and or how we can explain the ATPV and EBT in other terms? So if an EBT value is determined and it's found to be equal to or below as determined the ATPV, then EBT value shall be reported as an arc rated value and noted as an arc rated. So if the EBT value is equal to or below the ATPV, then we will going to define an arc rating of that clothing based on ATPV and vice versa. So basically ATPV talks about the thermal insulative capability of the material, that this material can sustain this much level of the heat. So ATPV is basically the reflection of the thermal insulative thing or the capability of the material itself, while the EBT is about the tensile strength, that how mechanically or that fabric is strong that it will not going to break open first. So if the material exhibits more tensile strength than its thermal insulative property, then that particular specimen will be having less ATPV as compared to EBT. On the other hand, if the material has more thermal insulative capability than its tensile strength, in that particular case, the material will be having the property that it won't be opening, but the enough amount of heat will going to transfer through the specimen. Yes, any question on this concept? So question is whichever is better. If an exam they ask you whether you will going to select the personal protective equipment based on ATPV or EBT, being the final user on the end user we don't care about ATPV or EBT, because for us the arc rating is important. Whether that arc rating is derived from ATPV or EBT, it's no use for us, right? So
Right.
So the main thing is that we have to protect our employees or the people who are working. So we will be selecting our personal protective equipment based on incident based on calories per centimeter square or the ARC rating. So that's why it is advisable that you should not select your personal protective equipment for a particular job which is exactly matching the amount of incident energy available at that particular point. For example, for a particular job, the risk assessment determined that there is an incident energy of 12 calories per centimeter square is available at location A. Okay, so at location A, if you are performing job while wearing an exactly 12 calories per centimeter square of or arc rating cloth, so there is a chances that when there is a flashover happens, so still there is a 50% probability that enough heat will going to transfer through that specimen, maybe due to APT or ATB failure. So that's why it is always advisable to wear an higher rating personal protective equipment when you are performing job there. So for 8 calories per centimeter square, a person can wear 12 calories per centimeter square of suit uh, and will be safe to perform that particular job. So if he is exactly matching, then the chances are there that uh, he will be injured. Okay, so 70 does not endorse this thing or does not make this compulsory. It's one of the best practices which you can adopt as a part of your own understanding of the risk associated with wearing the personal or the arc rated clothing exactly matching the amount of incident energy available at that particular point. Normally in industries they are using 1.25 factor. Any idea of the financial information regarding different tires? Uh, no, sorry. It might be available on the individual websites because it might going to vary. Uh, it might be including if I talk in Pakistani rupees, PKR, few people have bought it. It's in at that time in 10 lakh in 10 lakhs when the dollar was around 160 170. So roughly you can have an estimation that it is between 5,000 USD to 10,000 USD or maybe different. There is a Vextex website. Vestex, you can search that website and can ask for the quotations or other personal protective equipment providers. So based on the ATPV and EPT now, these are the R flash PP category. In most of these suits are in arc rated suits, you will going to find written the calories per centimeter square, calories per centimeter square. So this is one of the table 130.5G is there, which directly talks about the calories per centimeter square. For example, how much calories per centimeter square uh, is available at that particular location during an arcing event, and what the arc rated clothing you have available in calories per centimeter square. This PP category method does not directly talk about the calories per centimeter square. It talks about the PP category 1, and indirectly that PP category 1 corresponds to minimum arc rated rating clothing of 4 calories per centimeter square. So if you see on the labels written PP category 1, you can think that this PP will going to provide you protection till 4 calories per centimeter square. Okay, and if you see PP category 2, then it can provide you the minimum arc rating of 8 calories per centimeter square. PP category 3 till 25 calories per centimeter square, and the PP category 4 till 40 calories per centimeter square. Okay. Any questions on this PP ratings or arc rating of the clothing?
Sir,
Yes, please.
in this standard, they are not going beyond 40 cals per centimeter scale.
That is basically the limitation of in this standard. It's limitation related to the PP category 4. So PP category 4 says about that it should have a minimum arc rating of 4 cals per centimeter square, 40 cals per centimeter square. So above that 40 cals per centimeter square, that will be again PP category 4. Yani that here it says that minimum arc rating of 40 cals per centimeter square. So above that will also going to fall under the PP category 4. But you have to make sure that what the for this particular PP which they are wearing, what the ATPV and EVT against which it is tested. On the other type of the personal protective equipment which are available now mostly in the field and industry, that mentions the calories per centimeter square. So there are PPs which are rated for 100 calories per centimeter square as well, 100, 110, 120. But why you will purchase those PPs or and you will allow your worker to work for that particular level of the exposure? So why not you are working to reduce the incident energy at that particular location? Why you are not adopting innovation techniques to increase the distance between the operator and the switchgear itself? Why you are not using digital technologies or the remote operations for those particular location? Why still those switch gears or normal switching point has not been changed to arc rated arc or arc resistance switch gear? So personal protective equipment, arc rated clothings are available above 100 calories per centimeter square. But if in your industries the incident energy is so much high, you should think about other thing, how you can reduce those incident energy at that particular location. Yes. Am I able to clarify this point? Okay, moving towards the PP layering concept. What's the PP layering concept is? So wearing a 40 calories per centimeter square suit, it's one option. But we know that those 40 calories per centimeter square suits are very heavy, very difficult to carry as well, and you cannot perform the jobs for the longer duration of time. So there is another concept of layering. Just like in winters we do layering. We can wear one jacket which is going to provide us enough warm condition, or we can use multiple layers of clothing in order to protect ourselves. So similarly in this domain, there is a concept of the PP layering. So but what one thing which we have to know, that 40 plus 12 will not be equal to 52. Okay, so here the concept is that if you are wearing a 40 calories per centimeter square with the overall or coverall with a 12 calories per centimeter square jacket, it might going to give you protection till 80 calories per centimeter square, 100 calories per centimeter square, or it might only going to give you a protection to a fraction above 50, or in some cases it has been observed that the overall arc rating of the system have reduced. So in Annexure M, it talks about this layering concept of there, and it says that to achieve an arc rating, why we are doing this this layering, because overall the clothing system weight will be reduced, and it will be and the wearer will be more more easy, relaxed to perform job for the long duration of time. So layering of an arc rated clothing is an effective approach to achieve the required arc rating. The use of all the arc rating clothing in layer will result in achieving the required arc rating with the lowest number of layers and the lowest clothing system weight. Garments that are not arc rated should not be used to increase the arc rating of garment or of the clothing system. The total system of protective clothing can be selected to take credit for the protection provided by all the layers of the clothing are worn. For example, to achieve an arc rating of 40 cals per centimeter square, an arc flash suit with an arc rating of 40 cals can be worn over the cotton shirt and the cotton pants. Alternatively, an arc flash suit with a 25 cals per centimeter square arc rating could be worn over an arc rated shirt and arc rated pant with an arc rating of 8 cals per centimeter square. So here 25 plus 8 normally will be equal to 33, but 25 plus 8 will going to give you or can give you a total system arc rating of 40 cals per centimeter square at the lower weight. So who will going to determine that 25 plus 8 is not 33, but it is 40, 50 or 60 cals per centimeter square. So we will be using this layering system together and will be performing the same ATPV and EBT test on those layering system in order to determine what is the arc rating, a total system arc rating, right? So in some cases they have mentioned that the total system arc rating cannot be determined by adding the arc rating of the individual layers. Actually, in some cases, it has been observed that the total system arc rating actually decrease when another arc rated material of a specific type was added to the system as the outermost layer. The only way to determine the total system arc rating is to conduct a multi-layer arc test on the combination of all the layers assembled as they would be born. So this is how it is this total system arc rating works. Yes, any questions on this one? All good. Okay, now as we have seen different examples of personal protective equipment up till now, so please refer to 70 standard 2021 to determine PP for the arc blast hazard. So we have seen that only the personal protective equipment which are covered, basically covered the shock hazard and arc flash hazard. There is no personal protective equipment available which will going to cover the arc blast hazard. Then moving to another concept of condition of maintenance. So why it is important for to have the condition of maintenance? Because we know that if improperly maintained or damaged equipment cannot be assumed to functional normally and to provide the protection for the operator that would be afforded by the proper installation and maintenance. So if we are not maintaining our electrical equipment correctly, or if we are not maintaining its functions correctly, so there is a chances of delaying, and firstly there is a chances of our flash is there, right? And the second point is that if we are not maintaining the right amount of maintenance, so it might cause increase in the opening of the breaker, and if it is the case, then it might going to cause increase in the incident energy at that particular location. For example, 5 years back, I performed this study for my system, and I come up with the risk assessment, and I put this labels on every point where I'm performing some servicing, operations, inspection, etc. and etc. So I put this warning label based on the risk assessment I perform. If I perform the risk assessment based on the incident energy analysis method, so this label corresponds to the incident energy method, in which I'm writing the voltage, R flash boundary, available incident energy in calories per centimeter square, working distance, and the minimum arc rating clothing required in cals per centimeter square. If I'm using the PP category method, I perform the risk assessment and I put the label based on this one. It mentioned the voltage, R flash boundary, it mentioned the working distance. Okay, but it directly mentions the PP category based on the table I have shown. Here, when we are using a PP category method, we won't be writing the incident energy, available incident energy, or the minimum arc rated clothing. No, if we're going to write it, then it will be wrong thing. So I performed this thing 5 years back. Now, due to poor maintenance, the equipment has not been maintained over the period of time correctly, and its device tripping time has increased, or the fault clearance time has increased. So a person who will be wearing the personal protective equipment based on the risk assessment performed 5 years back, and due to non-maintenance or no maintenance, the device clearance time have increased. So there are the chances of fatal incidents or a serious incidents there in those particular case. So that's why the condition of maintenance is important in 70, and it has included a chapter number 2 related to maintenance purpose as well. Again, referring back to the table, here you can see that in this table they have mentioned the device clearance time 0.24, 0.24, or 15 cycles, 2 cycles. So these are the device clearance time. So device clearance time will going to change if the equipment is not maintained over the period of time correctly. Yes, any questions on this concept before moving to next definition? Okay. So what is the definition of de-energized? De-energized is free from any electrical connection to a source of potential difference or from electrical charge, not having potential different from that to the earth. So de-energizing, the term de-energization is not equivalent to electrically safe work condition. So whenever in 70 or any other place you only see the term de-energized, that does not describe the condition of electrical equipment and should not be used for other purposes. So de-energized does not describe the safe condition. What describes the safe condition is when you describe that the equipment has been put into an electrically safe work condition. Okay, so once an equipment has been put into an electrically safe work condition, de-energization is one of the steps within these steps for creating an electrically safe work condition. So in exam, they might going to ask you that a qualified person has de-energized or the set circuit or the set of circuits. Now he is wearing the required PPs and going to perform the job. So just remember that de-energization is not equivalent to electrically safe work condition. So on de-energized equipment, no unqualified person is allowed to come and perform the job until and unless that equipment has been determined safe to work on. Right. Moving to next one, NFPA 70, E70B or NEC. So what's the difference between NFPA 70, E70B, 70C, NEC? So these are basically the three legs of a table. So if any one leg is broken, you might be able to create a safe working environment for the people who are working around those electrical equipment. So 70B define the best practices. Now in the new edition of 2023, 70B has become standard for electrical equipment maintenance, just like standard for electrical safety in the workplace. 70B has transformed from recommendation or recommended practice to standard for electrical equipment maintenance. So 70B talks about the maintenance requirement. It talks about detailed maintenance on each and every piece of equipment. 70E is about the standard for electrical safety in the workplace, how you will going to safely perform operation and job on the electrical equipment. 70 or NEC basically cover the National Electric Code, how you will going to install or how you will going to select the electrical equipment, etc. So here in this course and in the CSP exam, what we consider that the electrical equipment has been correctly designed, selected, and installed as per the NEC requirement. It has been maintained over the period of time correctly as per the 70B. Now we have to perform job on that particular equipment which has been selected correctly and which have been maintained over the period of time correctly. So 70E talks about safe work practices on equipment that is basically safe since its installation, and it has been maintained correctly over the period of time. But in exam, they were going to test your knowledge that a qualified person determined that this equipment has not been maintained for 10 years and it has missed its maintenance cycle or its maintenance routine, which is expected that this equipment should be maintained every 3 years. Is it safe to work on? So the answer is no. So in this type of the question, you will going to find an exam as well. So if we look into some international level, like asset management, electrical asset management concept, so it is defined as an electric asset life cycle. So electric asset life cycle, if we look into, you need to define or identify an electrical asset which you need to purchase or procure for your organization. You select it, you purchase it, you install and configure it, and then you maintain it, operate and maintain it for its considerable period of time, and finally you sell it or recycle it. So this is normally a life cycle of a particular asset. Okay, this is as per the Institute of Asset Management Anatomy, asset life cycle. If we try to compare that asset life cycle with the electrical safety wheel concept of NFPA documents, you will going to find there are 3 set of document: NFPA 70, NFPA 70B, and NEC. So NEC basically covered these things: identify, select, purchase, install, and configure. So it talks about the initial phase, so that you have the right standardized equipment. You are installing it correctly, you are selecting it correctly, you are installing it correctly. 70E talks about how you will going to operate it or how you will going to work on it. So here it's not directly related to the operations, but it relate to how you will going to perform your task safely on that particular equipment. 70B is related to the maintenance requirement, how you will going to maintain your electrical equipment correctly. So if in any case in your organization, if there are any incidents happening due to any reason, you need to come to know what actually caused that incident in your organization, because NEC talks about, or it reduces the exposure under the normal condition, and NFPA 70E reduces the risk under abnormal conditions. So what is normal and what is abnormal condition? If the equipment was correctly selected, designed, installed, okay, so those are basically the responsibility of the NEC. So this is normal condition. Under normal condition, this equipment should not cause me electric shock. This equipment should not cause me flashover. This equipment should not be carrying any hazard, because I'm not interacting with those electrical equipment currently. So this equipment need to be safe as per the NEC NEC guidelines or NEC requirements. So NEC reduces the risk of shock and arc flash under the normal condition. Now, if I open it to see its bus bar or want to change some fuses, etc., now the responsibility shifts from NEC to NFPA 70E, because now I am myself is putting myself in danger. So I have to adopt safe work practices. Before that, if it was closed, I was not interacting with it. That was basically the responsibility of NEC to provide protection or safety to the people. So the when the equipment is operated under normal condition, worker is not exposed to energized part. So if this equipment was properly installed and it is properly maintained, so that equipment will be considered under normal operating condition. I can come and I can perform its operation. Maybe it is providing supply to some lightning loads. This might be providing some supply to HVAC system, etc. So I can perform. But if it fails and or if this equipment has not been maintained over the period of time, then it will not be considered under normal operating condition. Then I have to follow the practices given in NFPA 70. On the other hand, if I'm opening it to check what is basically the issues with it, then it is directly responsibility coming under NFPA 70. Yes, am I able to clarify this concept between 70E and NEC?
Yes, sir.
Yeah, any other issues? Okay, moving forward. So what are the factors which causes different type of the incidents uh, in an industries? So all the accidents and the incidents in the industries are not related to NEC failure. So if for example, if any type of the incident you have witnessed, or you are basically the part of root cause analysis team, and you have been assigned this task to identify what actually caused that particular accident. It will not be always the NFPA 70E responsibility for any arc flash or arc blast event. So first you have to think whether there was any interaction with those particular equipment, any person was interacting with those equipment or not. If they were not interacting with those equipment, and there was an arc flash and an arc blast event occurred, so you won't be finding solution in NFPA 70, because NFPA 70 is about the safe work practices. So there was no human error involved, or any bypass of any policies and the procedure. So you will going to find the reason of that thing due to NAC non-compliance or NFPA 70B non-compliance. So there are a number of reasons I have noted, which might cause arc flash and arc blast event, like dust and impurities, corrosion, water ingress, accidental contact, dropping tools, over voltage across narrow materials, failure of insulating materials, human error, faulty equipment, poor preventive maintenance, electrical equipment and system design, system operations, and other factors. So if we try to map those things as per the NEC non-compliance, NFPA 70B non-compliance, or NFPA 70B non-compliance, you will going to find that there could be number of factors which could be common in one standard and also in another standard. For example, what you found that this R flash event occurred due to water ingress. So what actually caused the water ingress? It was due to poor design of the equipment or poor selection of the equipment. If it was the area where there was a chances of flooding, or if it was an area where actually you will be installing some equipment outdoors, so it is understood that it will one day or another due to raining condition, or maybe due to other type of the reason, maybe some water pipe failure or etc. That asset might come under the under flood condition. So why water ingress? So it was due to the poor design of the equipment itself or the poor selection. Yeah, that means IP rating were not followed. Corrosion. So why you have installed this particular equipment in high corrosive area near seaside or shore, where there is a chances of corrosions are there. Okay, so again, this is due to wrong selection of the equipment. Then over voltage across narrow gaps. Why the equipment were not designed uh, with the right amount of gaps, uh, and due to this reason it has resulted in the flashover. Failing of the insulated material. Why the right amount of material were not used, and that caused the insulation failure. So it was the wrong selection of the material, which has resulted in that incident. Or electrical equipment system design issue, dust and impurities, again due to IP rating issues and other factors like rodent have entered into the electrical equipment. Why there were openings there. Similarly, NFPA 70B non-compliance could be dust and impurities. Okay, the equipment was designed with the IP rating, and it was mentioned that this much amount of dust and impurities will be accumulated over the period of 2 years, 3 years. So you have to have a maintenance defined maintenance strategies which will going to remove those dust regularly, maybe after 1 year, 2 years, or 3 years. So NFPA 70B was not followed. Yani the equipment maintenance were not followed. That's why the dust and impurities accumulated, and it causes of an incident. Corrosion. Okay, the electrical equipment were selected and designed for, and it was mentioned that this will be the rate of the corrosion. You have to maintain those electrical equipments or the installation by proper maintenance, by applying non-corrosive materials in order to either stop or lower the corrosion process. Water ingress, maybe after maintenance, the maintenance people did not put their backplates or the front covers in the right manner. That resulted in the water ingress. Faulty equipment was not maintained, and it had become faulty. Poor preventive maintenance. Failure of the insulating material. Okay, if the material have failed, or the insulation have deteriorated or failed, so why the maintenance have not picked up those issues, right? Or if you determine an R flash event have occurred when these were the condition, but the qualified person were interacting. So in that particular case, the thing is with the qualified person as well. So NFPA 70E non-compliance from the qualified person's point of view. Accidental contact, dropping tools, human error, system operations, other factors, poor workmanship, lack of competency. So these are directly reasons as stated in NFPA 70. Other things could be faulty equipment itself. A qualified person should identify before working. So if the equipment was not maintained correctly over the period of time, or the equipment was faulty, so why the qualified person did not identify those things and inform the concerned person before operating those that particular equipment. Poor preventive maintenance. Why an electric why the person performed the operations on the equipment which was not properly maintained. So it is from the qualified person. So these are the responsibility of a qualified person to identify whether the equipment is faulty, it has some intrinsic issues, or it has some historic issue that this type of the equipment have those issues here. Or poor preventive maintenance. the equipment have not been maintained over the period of time correctly, or electrical equipment system and design issue. So if there is some rotary type of the switchgear are there, so for those type of the switchgear, there is always an issue there. So before operating those electrical equipment and system, a qualified person should know about the system itself and take the required measures accordingly. So if any incidents happening in your organization and you have been assigned the task to do to do those root cause analysis, so it's a responsibility of a qualified person to check those things, or to identify whether this incident happened due to which reason, whether it was due to an FP70 issue, whether it was due to NAC problem or an FP70B. So in exam, they will going to test your knowledge. They will going to put forward these type of the question and will try to understand your and will try to test your knowledge and understanding whether all the incidents and the accidents which are happening in the organization, you are only directing those and you are associating those with the NFPA70E, or there are other non-compliance which can result in those incidents and accidents. Is any questions or any clarification required on this concept? All good. Right. So if no question is there, we will going to stop here today, and we will be continuing on Friday, inshallah. Okay. Yes, Mr. Janse, Mr. Zishan.
Sir, I have a question.
Yes, please.
Sir, after quick maintenance, I witness that still these false alarms also happening in our plant. Some areas, not everywhere, and I don't know the reason. They are telling, electrical department is telling that we have done the requirements, preventive, and there is weekly and there is monthly maintenance, and still the false alarms happen.
Yes, so if it is a false alarm, or if it is an actual issue but it is not been able to identify, so there is a difference. So if it is a false alarm, then you may contact the installing party to confirm or to check with the vendor why this false alarm is happening. Okay, so it is nothing to do with the NFPA70E then.
Okay, sir. Okay.
Right. Thank you all for joining. See you on Friday. Assalamu alaikum.